Question number 29. In the system of equations above, A and B are constants. For which of the following values of A and B does the system of equations have exactly two real solutions? In my mind, when it says exactly two real solutions, that reminded me of the discriminant. Now, I actually think that I worked it out, this is not the easier way to do it. The easier way to think about it would be in terms of graphically, but let me at least explain to you what discriminant means. The discriminant is the b squared minus 4ac we get from the quadratic formula. So if you have a quadratic equation and you want to know if you're going to have 0, 1, or 2 real solutions, it really depends on whether or not you get a 0 here inside the square root, or you get some positive number or a negative number. A negative number inside a square root is not going to create any real solutions. It would create imaginary solutions. And then a 0 here would mean negative b plus or minus 0. That would just give you the same one answer. But if you want exactly 2 real solutions, then this has got to be greater than 0. That's the discriminant. We will discriminate your equation and figure out is it a category of 0 or 1 or 2 solutions. That's what it means to discriminate, to put into categories. So anyway, if you have two y's here, you can say that 3 is equal to all of this. 3 is equal to a x squared plus b. And if you subtract 3 from both sides, you set it equal to 0. You get 0 equals a x squared plus, not b. This is not the b value you would expect from like this. This b and this b are two different things. This is the b in the quadratic formula, and this is the b that they're just saying that you have to use. It's actually a constant. If this said ax squared plus bx, then that would be different. Then this b would describe what this is. But actually the b value, when we're talking about quadratic formula, is actually equal to 0. This b that we're talking about in the equation is actually a constant. So if you want to know what the a value is, it's a, and if you want to, the b value is 0, and the c value is b minus 3. So b squared minus 4ac would be 0 squared minus 4 times a times c, which is, in this particular problem, b minus 3. All right, so get rid of the 0, and you get this, and then divide both sides by negative 4, and you get this, remembering to have to flip the sign. I'm going to distribute at this point ab minus 3a, and bring the 3a over to the other side. When you add 3a to both sides, you get ab is less than 3a. Now, what you'd like to do is divide both sides by a. And maybe you could have done that, or maybe you would want to have done that earlier here. But if you divide both sides by a, you don't know whether or not a is positive or negative. In fact, here you can see there's 2 choices where it's negative and 2 choices where it's positive. So you could say that a is positive and go here. And if you assume that a is positive, then you can divide both sides by a and not flip the sign and say b is equal to 3. So if a is positive, b should be less than 3. Here a is positive, b is less than 3. Nope, don't choose c. Here a is positive, and b is b less than 3? Nope, don't choose d. So here, if you assume that a is negative, because it could be, if you divide both sides, you would have to flip the sign, and we get b is greater than 3. So let's see, if a is negative, then you get either a or b, and so then here the b value is greater than 3, that would be answer choice B. Answer choice B falls into this category where b is greater than 3 and a is negative. Whew, that's actually a really complicated way to do it, and maybe it was a really good review for discriminant. I think an easier way to do it is depending on, maybe the easiest way to do this is to guess and check. You've only got 4 options. Depending on how quickly you can plug them into your calculator, it might be a good way to do it. So you guess and check, and eventually you see that this blue line right here, the y equals 3, and the green parabola intersect twice. That only occurs here at b when you type in y equals negative 2x squared plus 4. Y equals negative 2x squared plus 4 is right here. So that would be, I think, maybe the fastest way to do it. Well, no, the easiest way to do it might be a little time consuming. If you wanted a different way to do it, more graphical approach, you can say that a and b are only going to control how high, like b controls how high up the vertex is, and a controls how steep it is, or if it opens upwards or downwards. If you assume a to be positive, just like we said here, if you assume a to be positive, then it's going to go upward like this. And if a is going to be positive, then you need b to be less than 3 in order for it to intersect here. An intersection of the graphs would indicate a solution of the system. So in order to create two solutions, we need two intersections. And here they are. If A is positive, you have to make sure B is not too big. Otherwise, it'll miss the... if you move this parabola up here, then it'll go up too high, and there will be 0 intersections. So you have to make sure that you're satisfying these conditions, and none of them do. If A is greater than 0, then B is less than 3. Nope, the C or D don't satisfy this. But if A is negative, if the parabola is going downward like this, then you have to make sure that the B value is high enough to raise the vertex up this high. B has got to be greater than 3, and if B is greater than 3 and it opens up downward, eventually it's going to hit these two intersections right here. Two intersections mean two solutions, and that's what we're looking for, two solutions. So these two conditions are satisfied by answer choice B. A is equal to -2 and B is equal to 4. Like I said, you can choose whichever way you want. I'm pretty confident that this is too complicated to say that anyone would prefer this method the best. Maybe graphical, or maybe just guess and check.